Is there anything that says I only can work base 2? The answer is no. I can work in whatever base I want. So what if I looked at base 3? Base 3 is going to be similar to base 2. I'm going to have 1, and then I'm going to have 3s, and then I'm going to have 9s. 1s will be 3 to the 0, 3s will be 3 to the 1, 9s will be 3 squared. Now, what's the largest amount of 3s I could have? I could only have up to 2 3s, because if I get to 3 3s, I'm going to trade it in for a 9. So as an example, if I looked at the number 14, I'm going to look for what's the largest power of 3 that I can pull out of this. Well, 14 I can write as 9 plus 3 plus 2. So this is 1 times 3 squared plus 1 times 3 to the 1 plus 2 times 3 to the 0. And I'm going to pull off the coefficients here, just like I did with base 10 and base 2. And the result will be that 14 base 3 is equal to 1, 1, 2. And to show that I'm working base 3, I'll put a little sub 3. Let's see, can we apply the same method? Can we apply the same method of what would be dividing by 3s and then taking the remainders? So I'm going to try this algorithm. So 14 divided by 3 is 4 with a remainder of 2. 3 times 4 plus 2 is 14. That 2 is the remainder. Now if I do 4 divided by 3, I get 1 with a remainder of 1. If I do 1 divided by 3, I get 0 with a remainder of 1. If I read this in backwards order, we said we should do, then I'm going to get that 14 is equal to 112 base 3, which is the exact same thing we had when we converted it the other way of subtracting out the things we could. But it turns out that this algorithm does work. This algorithm will allow you to convert to any base. The reason that base 2 and base 3 are cool and important is that base 2 and base 3 allow you to encode things that might occur in problem-solving situations.